Can't hear you guys. Okay, there it is. I was just trying to get my audio working. Thank you. Yeah. Okay. Hello, hello. A little bit more. All right, and I know we got some people in the waiting room. Oh yeah. Oh, so let me let these brothers in first. Or do we have any sisters here? Okay. Right. Okay. So most people are doing what I need you guys to do. Uh, let's do this. Turn this down a bit. So hopefully you guys can hear me. This is actually my first official stream like on the road. I am having to travel for like just family reasons. It's a lot of loss. This whole COVID thing is really hitting everybody hard. So I'm like on the road. So I was like, well, that's the whole point of teaching remote. You can like take advantage of this stuff. So I was like, well, let me just try to be responsible and make sure I'm settled and have access to the internet and all that jazz. Let me see. So updates. So again, the way I intend to run the course, this is going to be an asynchronous setup where the main thing I need everyone to do is just check in each class period, like check in, make sure you don't have any questions. Like if you have any questions, get them answered. Otherwise, getting into the Zoom is how you get your attendance credit because I take attendance as I let students in. Give me just a moment. And so that being said, I did have a couple of students that just make sure that you have your student name showing in your ID. I know I had at least one student in another class that like he had like a different name. It was like Buddy Time. I was like, I don't know who Buddy Time is, but you're missing out on some money because I'm not letting you have my class until you fix your name. With the whole Zoom bomb and stuff. So just try to have your name showing so that I can. That's how I take attendance. So based on that. Um, but yeah, mainly you can just get attendance each class and you don't have to stay. And I'm really just going to use this meeting time to just answer questions and go through as much homework as I can. My intent or my goal is to pre-record all our video lectures and load the lectures in advance. So the lectures for this week are loaded. They are on my YouTube channel. If you go to Blackboard, as soon as you log in, you should see all the links for like the homework, my YouTube channel, accessing this Zoom session. It's all on Blackboard. The homework, so we're going to kind of just continue doing some of the homework today. Um, Let me check the chat to see if you guys have any questions. If you have questions, as questions pop into your mind, feel free to just either type it into the chat, or feel free to unmute yourself and just get my attention. But if it's quiet, if I don't see questions in the chat, or if nobody stops me, I'm just going to kind of work through homework questions as best I can. I hope everyone is doing well. Great to virtually see you guys, even though I'm not really requiring anybody to show faces or anything like that. But I'm glad that you're here and present and accounted for. Let me make sure I got myself some power. Um, but yeah, a lot of this is kind of self-directed. Again, through the use of my pre-recorded video lectures, and then just as you have questions, you come to class. You come to class every session to get your attendance credit, but you can get your questions. I'm going to take this time and devote it solely to answering questions. I think I. Oh, I hope that doesn't mess me up. Go ahead. Go ahead. Hello. Go ahead. Yeah. Mainly, like once you get into my Zoom, because I take attendance as I let you into the Zoom, so you don't once you get in, you see your name, just hang out for like a minute or two, and then you're free to go. Um, yeah, you don't have to stay. Yep. Yep. No worries, brother. I'm here for support. So we found. Go ahead. Mm, mm. Yeah, I get it. That's exactly the reason why I'm like switching to asynchronous because the technology can be kind of finicky, and so it's like it's too much of a struggle to try to get everybody here at the same time. To me, what's more reasonable make the videos in advance, and just be available for questions. So that's just, go ahead. Okay. Yes, that's exactly what it is. So the way we do homework, the way I'm doing homework, I was successfully able to link it to Blackboard. So you can just go through your Morehouse portal, log into our class on Blackboard, and as soon as you log in, like I think it's folder number 4, you'll see assignments, and then when you open up that folder, it'll say all my Math Lab assignments, and this should be the first link in that folder. Hmm. Yeah, so we do have to purchase full access. Like, uh, if you had My Math Lab before, only if it's the exact same book. So like if you're like, yeah, if it's a different book, then you have to purchase another access code. But like say I think, huh? The the course ID? Are you talking about the course ID or the access code? There is no course ID. The way you access it, you got to go through Blackboard. Is it still giving you a hard time when you go through Blackboard? It should it should be linked, like because like once you access it through Blackboard, the only other thing is the access code, which you had to purchase access for. So in the past, there were two things: the course ID to find the course, and then the access code is proof of payment. To find the course, I linked it to our Blackboard, and I did this maybe yesterday. So if you haven't tried since yesterday, then you know. But yeah, to act, yeah, you are gonna have to purchase it again. Like unless you only if you had an access code with. If it's not the same book, then yeah, you got to purchase another access code. And then to get into the class, you just access it through Blackboard. So Blackboard takes you to our class, and then you still have to purchase full access for your materials. It's okay. Yeah, I'm here. Once you got credit, then if you have to leave and come back, it's totally okay. These are go ahead. Yeah, that's exactly it. Yep, yep, that's it. Yep, this is good stuff. Okay, so let me see the time. I am watching the clock. Get a little bit of music on. Um, yeah, so it's like so. Yeah, we go until about 7:15 today. So yeah, we our class times we meet twice a week, Monday and Wednesdays, 6 to 7:15. So I updated Blackboard. I still need to like maybe load the syllabus there and a few other items, but I finally got my access back, so we're going to be communicating through Blackboard. Anything that you see me writing on the screen, I'm going to load a way to access that material into Blackboard as well. So all of our points of access are going to be passing through Blackboard. Okay, so if there aren't any other questions, what I'm going to do, I'm going to go ahead and hop over to the homework. Um, and you just have to stop me as you have questions as different things arise, right? So, oh, and let me switch it here. Let me close this out so I can see. Let's go like this and like this. That looks good. Okay, so we have homework for each session. Like I think this, like on Monday we did two sections, R4 and R5. They review from like stuff in the past, right? And I did homework assigned for each one. And then today I already did the lecture, the video lectures. Today I wanted to do work on sections 1, 1, and 1, 2. But any assignments I assign during the week, they're due every Sunday night at midnight, going into Monday, right? So Sunday night. But that's not the truth. The truth is they're due every Sunday. So you can actually submit them past the due date, but there's only like a 10% late penalty. So if you submit it past Sunday, you can honestly still get an A if you want an A on that assignment. It just has to be a perfect score. I had some students that do that. They submit everything very last minute, and then but they max out the stuff, so they get like a 90. I was like, okay, that's fine, you know. But so the official answer is all assignments on a weekly basis are due Sunday night at midnight going into Monday. But you can actually submit all assignments past the due date for a 10% late penalty, and we get unlimited attempts at everything, right? So yeah, yeah, you good. But this is I haven't. I'm just sharing it because I haven't shared it with like anybody. So I was like, well, let me dive into that stuff. So these are good questions. Okay, and then yeah, everything is going to be on Blackboard. Okay, yep. So everything is going to be there. Yeah. And so, and I did notice where like last class students started to group me. I think that's a fantastic idea. You guys need to be in communication and work together. That's recommended. I encourage it. Also, be aware that you know tutors are included in your tuition. You've already paid for tutors through Morehouse, right? So you have a lot of support between me, Pearson, your classmates, and tutors, and the internet. You can get it done. It's all there for you taking. You just got to reach out and take it. That's really the name of the game here. Okay. And yeah, keep the questions coming. That's the whole intent of this time. And again, there are lectures associated with this homework set that I'm going through, but I'm going to leave. You're gonna. I'm going to leave it for you to watch the lectures on your own, and then just bring your questions. Either email me or ask me during class time um, for any questions that you have. This music. Uh-huh. Yeah. Uh, is it not automatically taking you to the prereq? Okay, I got you. Hang on, hang on. I got you for that. So what I'm gonna do is hop here. Yeah, you just open the link, and it's just I just want you to be aware of how to find my YouTube lectures, and if you go back, you get credit for it, and you're good to go. Yep, yep. Okay, so what I'm gonna do, I'm like getting lost in the music now. I just want to listen to music. So what I'm gonna do, I'm just gonna go ahead and work on the homework that's associated with the lecture that's for today. The lecture for section 1.1 and 1.2 is pre-recorded. It's already on my YouTube channel. So what I'm going to do is just kind of start on these assignments. Let's see who we got. So we got another. See, I don't know who that. I think so. Hang on. Is that a, anyway? All right. Cool beans. All right. So let me see. And I like to do this paper. I like to work on graph paper. Okay. So let's start with section. So today we're going to start with section 1.1, and I'll just kind of talk through like anything that's pertinent that's I probably have already said in my video lectures, but I'll fill in as we kind of go. So my recommendation is try to watch those lectures in advance as much as possible, as soon as possible. It's better to watch those before I start going through the homework, but I get that you probably haven't done that because we're just kind of getting started and getting used to everything. So this one says, this is coming from section 1.1, limits a numerical and graphical, I think it's approach. We actually simplify by removing factors of 1, okay? So I'm actually going to write this down, take some notes, and walk through this example, okay? Oh, this is a little bit awkward. Can I like raise this chair? Oh. Where is it? That's okay. All right. So, let's do like this. Okay, you're working. Oh, okay. I'm just being goofy. Are you slowing down on me? A little bit. Give me just a moment. I'm going to reboot this so it won't be so laggy. I'll be right back, guys. It's looking good. And then this one is kind of messing up too. Reload. I have to fix it later. And I was here. And let's go like this. Yeah, he was already here. Cool beans. Hopefully we're done with the new people coming in, so I'm gonna just close that out for now. Okay. So let's see. So this is section 1.1, limits a numerical and I think it's supposed to be a numerical and graphical approach. A numerical and graphical approach. Okay. So this is question number 1 from the homework. This says AR 611. Okay, I'm gonna let that be for now. So it says simplify, so I'm just gonna put simplify. I'm just getting a copy of the original question. And then, so we have this s squared minus 4s plus 4 under s squared minus 4. Now, as you guys work through the homework on your own, as you need support, this is the reason why I personally vouch for Pearson, is this question help. It's very user-friendly. Let me see. So this one doesn't have all, this specific question doesn't have all the tools, but like the viewing example, typically what they do is they'll give you the same question with different numbers, and then you try to match it up, and they'll give you an explanation like from beginning to end of the thought process behind it. This one, another powerful tool is the Ask My Instructor. So say you're working something and you just can't, between you, your colleagues, tutors, you can't figure it out, click on Ask My Instructor. And I really like it because it'll send me a screenshot of the very question you're working on. I'll load it to my tablet. I make dedicated YouTube video walking you through it, and I'll send you the link right back to you, right? That's usually what I do. And I do the best that I can. Sometimes I do get behind, but yeah. So let's hop over here so you guys can see my tablet. Okay. So this is the question, right? This is question number 1. We're asked to simplify this, and this is what we're given. Okay, so what I would do here, first thing I notice, oh, well, this can be factored, right? So if you look at the top here, you have something squared minus something squared. So hopefully that should jog something in your memory, right? Difference of squares, right? That's difference of squares. Difference of squares factors into, this one is going to be s minus 2 times s plus 2, right? And then the bottom, we got a trinomial. So we want to see, can we factor that trinomial into a form like this? We're going to have s and s. This plus means that our two signs are the same. This sign tells us that they're both minus, all right? So then we can anticipate a minus and a minus. And then we're looking for two numbers that multiply to give us positive 4 and add to give us negative 4, and it should be clear at this point. It should be minus 2 and minus 2, right? I know a lot of students have several ways of factoring stuff like that, like the box method, and I'll try to touch on those as they arise and things of that nature. So then at this point, now we see that this s minus 2 can cancel this one. We have everything in multiplication and division, so we can cancel. And then that leaves us with the following. We have this s plus 2 over s minus 2, right? That's about all we can do there. I don't even see anything else beyond that. So my recommendation is, as you kind of work through this homework, you want to definitely have a homework notebook where you kind of you document all of your work. So you have a copy of the original, write the original question, or copy it however you see fit. Show all your supporting work, box your final answer. Because what's going to happen is when the exams arise, you don't want to be fooled by the same question twice. You know what I mean? Like, you be like, oh, wait a minute, we just did that. Let me look and see. And then you just update the numbers and then, keep it moving. But if you're not organized, if you don't write things down, you can get fooled over and over. And then it's just, it's just waiting for you to catch on to pick up the pattern. Let's see, how do we do? We got s plus 2 over s minus 2. Cross our fingers. Awesome sauce. God is all the time. Okay, on to the next one. Simplify. Let's do another one. All right, so hopefully knocking off the cobwebs, things of that nature. So this is going to be question number 2 from that same section. It just says simplify. Okay. So the denominator I have is x squared plus 5x minus 24. And then the numerator is 3 minus x. Okay, let's hop over and check out the tablet. Like this, boom, looking good. All right. And just feel free, let me check the chat. Feel free to either type in the chat or unmute yourself if either my pace is too fast or if things is not clear. Let's see, group me chat. So there is a request for the group me. Definitely get that going, guys. I recommend that. I know I did it when I was a student and just did what I had to do. I totally get it. I ain't making no big deal about that. I'm just trying to help you guys along your way. People help me. I'm just trying to pay it forward, keep it moving. Okay. So basically, this is factoring. I don't know if you heard that or not. My voice cracked like I'm in puberty. It's so funny. It happened just now. I was like, "Were you like surprised with that?" So if we look at the denominator, right? Let's try to factor that denominator. Man, what is going on with my voice? It did it again. So we got x and x, right? Two numbers that multiply to give us negative 24 and add to give us 5. So I'm actually going to work this off to the side, right? We're looking for two numbers that multiply to give us negative 24, right? So let's list out the factors of negative 24. What times what gives us 24? Well, there's 2 times 12, but then 12 is 2 times 6, but then 6 is 2 times 3, right? So then 8 times 3 gives us 24. So then what I'm going to do, I'm going to go through all the factors until I get to the line that adds up to 5, right? So the first things that multiply to 24, we have negative 1 and 24, but that adds up to 23, so I'm going to go on to the next one, all right? Like this, okay? So then we can do 2. So if we use 1, 2, what's left over? 4 times 3, we got 12 left over, right? So then 12 times 2, but that adds up to 10. We're almost there. It's moving very quickly. Okay, can we do 3? There is a 3 in our list, so we can do 3. If we use this 3, we have 8 left over, right? So then notice, negative 3 times 8, negative 3 times 8 is negative 24. Negative 3 plus 8 is 5. So these are the two numbers that we were looking for, okay? So then we have a negative 3 here and a plus 8 here. Boom. That's the denominator, okay? I call that the AC method of factoring. That green part that you saw me do to the upper right-hand corner of the screen. Now the top, I have the variable is the second term. I'm going to factor out a negative 1 so that I can move the variable to the front, right? So if we factor out a negative 1, then the top can transform into like x minus 3, right? Now we can see where something cancels. Notice that all of our factors, everything is either being multiplied or divided. We can cancel factors, but we cannot cancel terms. Factors are things that we multiply and divide. Terms are things that we add and subtract, right? So because everything is now in the form of multiplication and division, we can cancel the things that are being multiplied and divided, right? So, long story short, this can cancel this, okay? And that leaves us with the bottom is x plus 8, and on top I think we still have a negative 1. So now with questions like this, you know, we don't have the luxury of checking other than just going back and being meticulous. Like we don't, you know, maybe unless there's some technique that I'm just not aware of. But, you know, it's kind of hard to check something like this. Okay, let's hop back over to Pearson and see how do we do. So we got the following. We got negative 1 over x plus 8. I feel like a DJ with this music. Like I'm doing math, but it feels like a DJ. And then I'm waiting for the bass to drop, and I'll be like, you know, anyway. Just being silly, just try to have some fun when we're doing what we got to do. Just trying. I know it might be whatever, but just trying. Okay, choose the graph. Oh, this is number 3. So we have a piecewise function, all right? Actually, let's not do it that way. This is fine. I'm going to just leave it be. So we're asked to graph this. So a piecewise function, all it is just like you would just graph this first line as like if it was y equals negative 2, just graph it like normal, but keep only the x values that are less than or equal to 2. Graph y equals x squared like normal, but then this says to keep the x's that are strictly larger than negative 2. Right? So to the left of negative 2 is going to be a horizontal line. That's a solid line, a horizontal line through y equals negative 2. So it can't be A. It also cannot be D. So it's either B or C, right? Here's y equals negative 2, so that's checked out. And then the second part, this is just a regular y equals x squared, but we keep the numbers to the right of negative 2. So see how this x squared has been moved up, so that can't be the right one. So then this should be it, B. We can actually graph this in like a graphing calculator. You can also use, I think, let me put this in our notes. Let me hop over so you can see it. So some other sites that allow you to do like free online graphing. I'm a fan of geogebra.com. This is for free online graphing. You got GeoGebra. I think another one that students use is, I think it's called Desmos.com. And yeah, I use an emulator that I found some students made. I use this site called cekimtech.net, but that takes a lot of effort to get that operational. The top two, the other two, they're a lot more user friendly. Okay, so let's hop back to Pearson. Okay, so my vote was for B. I'm gonna go with that one. Cross my fingers. God is good. Okay. On to the next one. All right. So this is a repeat. This is another piecewise function. Oh, so some of these, I guess he's still in review, right? So this is still a review question for this homework, but that's fine. So we're asked a graph. This one, okay, it says if x is equal to -2, so that's just going to be a point. -2, 5, and that's going to be a solid point. So -2, 5. Only one right off the bat that has a point at -2, 5 is C. Because this one is -2, 5, but it's open. That's not correct. All right. This one is not -2, 5, so that doesn't have it. This also is not -2, 5, so that doesn't have it. What happened to my music? But yeah, I didn't even do anything else. The only one that has the correct point is C. So I'm just going to go with that one. Okay. What's the time? We're good on time. Okay, as x approaches 1, the value 4x plus 5 approaches. So in my video lecture, we kind of talked about like limits and like what do we mean as a function gets close to a point coming from the left and from the right. So we're concerned like what happens as x gets close to 1, what happens to this function. All I'm really going to do here is just plug in because there's nothing fancy going on. So 4 plus 5 ends up being 9. So I'm just going to go with 9. Okay. So, but that question was concerned about as x gets closer and closer to 9, y gets closer and closer to what, right? So the notation blank is read, the limit as x approaches 2 from the right. So the limit as x approaches 2 from the right, coming from the right is the positive side. So right here, C. It should look like this. C is read, the limit as x approaches 2 from the right. So that's going to be C. Okay, next question. And anything that you see me writing, like on the screen, I'm going to load a PDF or I'm going to load a link into our Blackboard page for you can get a copy of all the stuff you see me writing. Let me see, we still got any? Okay, we got a pretty decent crowd. I'm going to keep it moving. The notation blank is read. Okay, this is the limit as x approaches 5 from the left. The limit as x approaches 5 from the left of f of x. Yeah, let's go A. Okay, let's go here. I'm totally distracted. Like I got group me's going with people chatting about stuff and following people on YouTube, like gamers. I'm a gamer, so it is what it is. I stopped fighting it a long time ago and just try to create the life I want doing what I want, like as much as possible. Use the graph of f to find the given limit. When necessary, state that the limit does not exist. So the limit as x approaches 2. Okay, so let me kind of reference some things that I said in my video lecture. So for a limit to exist, as we approach a number coming from the left and coming from the right, they have to approach the same number, right? If coming from the left, you approach one number, and coming from the right, you approach a different number, then we say that limit does not exist, right? So this is the limit as x approaches 2. So if we come over here to the graph and look at when as x approaches 2, so x equals 2 is here. So coming from the left, y gets closer and closer to 6. Coming from the right, y gets closer and closer to 6. So the left-hand limit equals the right-hand limit. So we say the limit is going to be 6 in this case. Okay, let's go on to the next one. Let's see, decide from the graph whether a limit exists. If a limit exists, find its value. The limit as x approaches 4. Okay, so let's look at the graph. So as x approaches 4, now notice, even though this function is not defined when x is 4, like when x is 4, it's actually undefined. But coming from the left, y's get closer and closer to the value of 4. Coming from the right, y's get closer and closer to the value of 4. So even though this is not defined when x is 4, because the left-hand limit equals the right-hand limit, we say the limit exists, and in this case, the limit is going to be 4. Hopefully that makes sense, right? The limit is concerned about being close to a point, not at the point. Continuity is where we're concerned not only close to the point, but the value at the point as well. Okay. Use the graph of g shown to the right to find the limit if necessary. Okay, the limit as x approaches -3 from the left. So here's -3. Okay. So I think we mentioned something about a wall method, right? So if you could imagine a wall at x equals -3, notice coming from the left, it hits the wall at a value of 2. Coming from the right, it hits the wall at a value of 0. So because the left-hand limit and the right-hand limit are not equal, then the limit does not exist. All right, hopefully that makes sense. Let me check the, -3, right? Limit does not exist. Oh, from the left. Okay. So I was talking about the limit overall. This one's just the limit from the left. Okay, so the limit from the left is just going to be 2. And then it's probably going to ask me another question. What's the limit from the right? No? Man, I cannot anticipate these at all. Okay, this one is the limit as x approaches -3. So -3 is here. So coming from the left, it approaches 1. Coming from the right, it approaches 1. So this limit is 1. Okay. Okay. X approaches 1. So 1 is here. So coming from the left, it approaches -2. Coming from the right, it approaches -2. So this one I'm going to say is -2. I don't know. I don't even know how to get rid of that. Okay. Go ahead. It is that's a reciprocal. That's a graph of a reciprocal function. So you notice we have a vertical asymptote. We have asymptotes. That's honestly from college algebra, but you don't. I know they've done some revamping, and you don't have the chance to get into those kind of graphs like we should. Right here, like this is x equals -3. There's a vertical asymptote here. This is another vertical asymptote, x equals 2, right? So that means that in the denominator of that graph, you're going to have x plus 3 and x minus 2, right, in the denominator. And then you have a horizontal asymptote. It looks like it's the x-axis. So the numerator has to be like, the degree has to be less. There's a lot. It's a lot. This graph does come from college algebra, but the main thing they wanted you to do is just look at the graph. You don't have to worry about generating and identifying and all that with this one for right now. And like, we'll try to work with you because I know, like, I remember before they revamped college algebra, we got into stuff like that. But we'll kind of address these things as they arise. Okay. Also, with these assignments, as you start working through them, gentlemen, lady, I don't know if there's a lady in here or not. I saw a name, I wasn't sure. But for right now, I'll just say gentlemen because I think it's on man. But as we work through these assignments, just breathe. Like, you get unlimited attempts at all of them. I mean, the homework, quizzes, and the exams. It's only a 10% late penalty after the due date. And exams, I usually give you like maybe like 4 or 5 days to work on it before I start taking the late penalty. But you get unlimited attempts. So as long as you just keep doing it until you get essentially whatever letter grade you want, you can honestly do that. So just breathe. And I do the best I can to try to set it up where you guys can get ahead if you want. Because, it's going to come to that point where all your classes are going to want everything at the same time. But if you're already done with mine, then that should help lighten the load some. And I like it to be able to do that, to try to be cognizant that, hey, I know you got other classes and things of that nature. Anyway, yeah. Okay, let's go on to the next one. That's a good question, though. But yeah, that's a reciprocal function. That's what these are. These little images like this. This is like the 1 over x kind of stuff. But it says use the graph on the right to find the limit. So the limit as x approaches -4. -4. Let's look at this graph. So -4, there's a vertical asymptote. So now notice, coming from the left of -4, it goes off to positive infinity, way up here, right? Coming from the right of -4, it goes to negative infinity. So because the right-hand limit does not equal the left-hand limit, this is an example of where the limit does not exist. Okay. All right, graph the function and then find the specified limits. So now we can actually graph this one with transformations, right? Because the parent function here is absolute value of x. We could factor out that 4, and so that can be like 4 times the absolute value of, what is that, x plus 2. So then let's graph this, because we can graph it using transformation. So we're going to have a v. Let me think about the vertex. So when we have the x plus 2, if we use transformations from college algebra, that says to move it, what, left by a factor of 2? And then if we multiply the outside by 4, that's going to cause a vertical stretch by a factor of 4. So instead of going through that 1, that y needs to be, it needs to go up here to 4, like that. And I think that's going to be the graph. So I use transformations. You don't have to use transformations. That discussion comes out of college algebra. You could have also like just made a table, right? So for instance, when x is -4, right? If we plug in -4, -4, that's going to be a -16. That's going to be -8. So that's 8. You see it here. -4, 8, boom, is right there. When x is -3, so on and so on. You can make a table and plot the points, and that'll work too, right? But I use transformations from college algebra to do that. If I need to go into further details, let me know. Otherwise, I'm going to move forward, right? So, okay, so I'm going to check my graph, okay? Now, the limit as x approaches -2. Now, coming from the left, it's approaching 0, right? And coming from the right, it's approaching 0. So the left and the right looks like they're the same. I'm going to hit 0. Okay. -3. So over here, -3 is here. So the corresponding y value is 4. So coming from the left, y gets closer and closer to 4. Coming from the right, y gets closer and closer to 4. So the net limit is going to be 4. Okay. Let me kind of check the chat and see if we have any questions. Cool beans. We're looking good. Okay. I think you guys know how to unmute yourself and stop me. So yeah, if you don't stop me, I'm going to just kind of like power through as best I can. We doing pretty good on time. All right. So we're asked to graph this function. All right. So we have x squared minus 4, right? So again, transformations from college algebra, the parent function is x squared, so it's just a parabola. Then this -4 is on the outside, so it moves it down by 4. If you don't remember transformations, I know transformations were intense. You can just make a table. Choose some x values, find the corresponding y. This is also where that geogebra.com or desmos.com or your graphing calculator, you can actually graph these and just look at it. Like, that's totally okay too, right? So I'm going to go with D. Boom. As x approaches 2. So let's make this a little bit bigger. All right. So x is 2 is here. Y gets, coming from the left, it gets closer to 0. Coming from the right, it gets closer to 0. So then we say the limit as x approaches 2 is going to be 0. Because the left-hand limit equals the right-hand limit. So we're going to keep it moving. So notice we haven't really had to do a lot of writing. Also, I want to say that when you finish these assignments, you can print them off, like and save a copy. All right, you just want to be logging this stuff on some level, have a log of it, like make a notebook or something. The more organized you are, the better off you'll be. So that way, as the exams pop up, you know, you're like, wait a minute, I did that. You're not fooled by the same question twice, right? The limit as x approaches 1. So let's look at the graph. X approaches 1 is here. What is that? 1, 2, 3. So they both approach, the left and the right both approach -3. So we're going to say the limit is -3 because the left hand limit equals the right hand limit. Okay. Let me see what we're looking like on time. We got a good amount of questions. I'm just going to kind of keep going with these. Also, like if you want to like hop around, or if you have specific questions, like if you've managed to like work stuff in advance, and you want to you have like you want me to work over specific questions, we can do that as well. So for instance, okay, this one, there's my voice again. You have the reciprocal function 1/x, right? So we can graph this with transformations. We have a +3 on the outside. We have a +3 on the inside, and we multiply the outside by 7. So if we take a generic reciprocal function, which is just 1/x, and then this says to move left by 3 and multiply multiply the y's by a factor of 7. So it should just be where basically the vertical asymptote is at -3. One of these has been flipped upside down. So it has to be either B or D. And I think, let me think about it. Let me choose a test point real quick. For instance, if x is like -4, that's going to be negative, right? Yeah, so it should be B. Because B is the only one that's a reciprocal function that's been moved left by 3. Because this is the vertical asymptote. This will move to the right. This will move to the right. Go ahead. Okay. Yeah. So the generic form of a reciprocal function, there's a vertical asymptote on the y-axis and a horizontal asymptote on the x-axis. This +3 from college algebra, the transformations, that +3 is inside your basic function. So it moves it to the left by 3. So that what that means is that the vertical asymptote is here now. It's a dashed line. You can't see it, but there's a vertical asymptote here. If transformations don't resonate, I would just graph it in some way. Either make a table and plot points, use a graphing calculator, use GeoGebra or Desmos, use something like that to get a sense of the graph, and that's totally okay. Because I kind of got a little bit caught because like okay, I know it moved 3, but then I wasn't sure if it was B or C, so I just chose a point. I was like, okay, well let me see when x is -4, and then my y value was something negative. And so this one, the y value was positive, so that I knew that D wasn't right. So let me check my answer first before I go on. Okay, hopefully your question got answered. Yeah. Okay. So the limit as x approaches -1. Okay, so let's look at the graph. So -1 is here. It goes off to -infinity. Way down off the graph, right? You have to use your imagination there a little bit. So the left-hand limit, coming from the left, it goes to -infinity. To the right, I think it goes... Wait a minute. Let me think about that again before I do this. Let me look at this again. Because the asymptote here was at -3, right? That's still really, really far down there. Oh, actually, no. I'm totally reading this wrong. I knew something wasn't right. Okay, so -1 is here. The graph intersects here. 1, 2, 3. That looks like maybe 3.5. So when x is -1, 7, yeah, 3.5, right? Let's look at that again. I was just about to get them wrong. Something caught my attention, right? So when x is -1, it crosses the graph here. So coming from the left, y gets closer and closer to 3.5. Coming from the right, y gets closer and closer to 3.5. The only point that's infinite, or the asymptote, is here at x equals -3, right? That's what caught my attention. So we say that the limit should be 3.5. Let's see, how do we do? Integer or simplified fraction? So -1, 7/2, right? 7/2. Okay, let's cross our fingers. We almost got that one wrong. We see the time. Okay. All right, let's power through. Okay, that was the one we said was the asymptote, right? So that's the one where we said the limit does not exist. Because the left and the right. One goes to -infinity and one goes to +infinity. So that limit does not exist. You have headphones? Do you want headphones? Okay. Let's see what we're looking like. Okay. So choose the correct graph. Graph the function. So to the left of -4 is 3x plus 12. To the right is just x. That one should be open, and then that one should be closed. Let me see. Are they the same? When x is -4, that's going to be what, 0? Okay, so they're not going to match up. I'm thinking A, right? The y-intercept is 12. It's going to be up there off the thing. Y-intercept is 0. The first one should be an open circle. The second one is a closed circle. Yeah, I'm going to go with this one. So again, the piecewise function, you just graph the first line like normal, but this says keep only the x values to the left of 4 with an open circle. Then the second graph is just graph y equals x like normal, but then keep the x values to the right of -4. And that's going to be a closed circle because of the bar. Okay, let's just check that. Boom. So now as the limit as x approaches -4 from the left. Okay, so coming from the left, it gets closer and the y values get closer and closer to 0. So the left-hand limit should be 0. Okay. And then the limit from the right side of -4, those are approaching -4. The y values there are approaching -4. So coming from the left, the y value approaches 0. Coming from the right, the y value approaches -4. So then the limit at -4 does not exist because the left-hand limit does not equal the right-hand limit. Okay. On to the next one. Okay, graph the function. So to the left of 1, it's just x squared. Okay. So when that's a 1, that's 1. When that's 1, that's also 1. So they should connect. To the right of 1, it's going to be -x plus 2. It has a negative slope, right? Oh, and notice there's no equal to, so it should be an open circle. This looks like A to me as well, because it's not defined when x is 1. That looks good. I'm going to go with A. Okay. Nice. So then the limit as x approaches 1. Now coming from the left, it approaches, what is that number? 1. And coming from the right, it also approaches 1. So we're going to say 1 because the left-hand limit equals the right-hand limit. Okay, next question. Again, let me check the chat and just stop me if you have questions. Oops, let's go here. I just want to check the chat. Dang, I know that was going to happen. Okay. I think I got to double click. Okay, that looks good. Give me a moment. I'll be right back. I'm going to leave this on the screen so it can kind of work. So give this one a go and give me a moment. I'll be right back. All right. Okay. Okay, we're good. Okay. What's the time? What do we say? 7:15. Okay, I'll keep you guys no more than about a little over 10 minutes. Okay. So let's give this one a go. Ah, shoot. Hopefully that doesn't slow down. Let me reboot it. Okay. That looks good. Okay. Let's see. Okay. So it says in a particular city, taxi cabs charge passengers $2.50 for entering a cab, and then 30 cents for each 1/5 of amount or fraction thereof travel. If X represents the distance traveled in miles, then C of X is the cost of the taxi fare, where C of X is going to be 250 if X is 0, 280 if X is between 0 and 0.2, so on. The graph of C is shown to the right. Use the graph to find each of the following limits. The limit as X approaches 0.51 from the left. Okay, 0.51 from the left. Here, let's do like this. Let's do like this. 0.51 looks like it's here. Coming from the left and the right, looks like it's both 3.4. Okay. So $3.40. Do not include the symbol. Okay. Okay. Continue. The limit is, yeah, the same thing, right? They're both 3.4. $3.40. Okay. There's one more part. So then because the left-hand limit equals the right-hand limit, it's the same thing. Okay, that wasn't too bad. Nope, don't cut off. Okay, the cost of sending a large envelope via first-class mail is 78 cents. For the first ounce, 16 cents for each additional ounce, or fraction thereof. X represents blah, blah, blah. The limit as X approaches 4 from the left. So let's look at the chart. 4 coming from the left is going to be $1.26. So 1.26. Okay. But then coming from the right, it's $1.42. Okay. So the limit does not exist because the left-hand limit does not equal the right-hand limit. Okay. Let me see the time. Okay, so we essentially made it through 1.1 during class. I'm probably just going to do the next two. Let me try to honor the time because it's very easy to like fudge on the time. I was like, no, let me just stick to honoring the time. If it's 7:15, I want to go to about right at about 7:10 is when I want to stop. The federal tax rate for blah 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 is given by the graph shown to the right. Use the graph to find these limits. Okay, so find the limit as X approaches to 87.79 from the left. 87.79 from the left is 8%. Okay. 87.79 from the right. What's halfway? Is that 12? So coming from the right, the Y's are getting closer and closer to 12%. Okay. So the limit does not exist because the left-hand limit does not equal the right-hand limit. Okay. Determine the value of c such that the limit as x approaches 2 exists. Okay. So you want the limit coming from the left to be equal to the limit from the right. So for instance, like if we plug in 2 here, what is that going to give us? It's going to give us 6. So we want this to approach 6 as well. So then we just set this whole thing equal to 6. I think x needs to be 2. This whole thing needs to equal 6. So then we can solve for c. If x is 2, that's going to be a 1. 1 plus c equals 6. So c equals 5. So it seems like c needs to be equal to 5. So that way the left-hand limit equals the right-hand limit. Okay. I could write that out if I need to. I was just hopefully what I said. Now, like say you're working on your own, you can click on this question help, click on view an example. You got the whole ebook here, right? But these are the 3 I recommend: view an example, or the ebook, or ask my instructor. Like those are the ones I would do. Okay. So to determine c such that the limit as x approaches 4 exists. Okay. So like if we plug in 4 into the first one, that's going to be 6, because it's 16 minus 10 is 6. So we want this one to equal 6 as well. So what is that? A negative 16 plus c equals 6. So what is that? 22? So it seems like c needs to equal 22. 22. Let's try 22. Okay. Oh, that was it. That was the last for that section. Let me see the time. All right, we got 10 minutes. Let me try to take advantage of this 10 minutes, right? So what I'm gonna do, let me hop back here. Let me go to assignments. I'm gonna go ahead and start section 1.2. So these are the assignments for the week. R4, R5. We did 1 together, and we're gonna go ahead and work on 1.2. And let me just set it up so I can stream. Come on. We're gonna start question 1, and I'm not gonna go more than past 7:10. So then let me hop over here, and I need to adjust this thing. Properties. It's this one. Okay. And then need that to be full screen. I can't remember my shortcut. There it is. And like that. We're looking about as good as we're gonna look. Okay. So section 1.2. Again, I already have a video lectures that I made specifically for this section. I tried to limit those presentations to 35 minutes each because if our class time is like an hour and 15 minutes and I was doing 2 sections a day, so I gave myself 35 minutes to kind of just make my way through those sections as best I could. Algebraic limits, and I think it's supposed to be continuity. Anyway, it may have got cut off. Simplify by removing factors of 1. So, okay, so another slight review there. So let me kind of take some notes here. So this comes from section 1.2, algebraic limits and continuity. Let's turn this down some. Algebraic limits and continuity. Okay. This is question number 1. This comes from section 8R 611. I think that's a review section. I'm going to say simplify. Simplify. The denominator we have is t squared minus 10t plus 25. Okay, look, we got some chat business. I'll check it. Let me finish this first, and then I'll check the chat. Then we got t squared minus 25. Okay. So let me check the chat just in case. Okay, cool. Let me hop over to the tablet. Okay. So again, you see the free online suggested tools. You got GeoGebra, Desmos, and I'm using Kimtech, but that takes a lot of effort to get that set up. But once you get it set up, it's really nice. Okay, so basically this is factoring, right? So let's start with that denominator. So we want like a t and a t. Two numbers that multiply to give us 25 and add to give us -10. Looks like -5 and -5. So -5, -5. And then the top is difference of squares. So you're going to have t minus 5 times t plus 5, right? So now you should see, it should be clear that something can cancel. So this can cancel this. And this leaves us with t plus 5 over t minus 5. Okay. All right, so let me go back and check it style. It's like this. Okay, let me hop back over to Pearson and check that work. Simplify by removing factors of 1. So we got t plus 5 over t minus 5. T plus 5 over t minus 5. Okay. I think we got time for one more. Then we'll call it a day. Yeah, we'll let this be the last one. Okay. So this is question number 2. This is question number 2. Let me check something. Cool beans. I don't know how to redo, but that's okay. Question number 2. This comes from AR 614. AR 614. Okay. Basically, we need to simplify. Okay. The bottom we have is x squared plus 4x minus 32. And the top is 4 minus x. Okay. All right, so let's hop over to the tablet so we can see what I'm writing. Okay. And next I'm going to move this to the second page. The next page. Okay. So let's factor. So it looks like the denominator, we want to factor it into something of this form, right? We got x and x. Two numbers that multiply to give us -32 and add to give us 4. Let me go through the list. So -32, right? What times what is 32? That's going to be, what, 2 times 16, but then that's 2 times 8, but then that's 2 times 4, but then that's 2 times 2, right? 1, 2, 3, 4, 5, okay? So I'm going to go down the list until I get to the line that adds up to 4. So then we got, what, -1 and 32. But that adds up to like 31, so that's no good. We can do -2 and what we said 16, but that adds up to 14, so that's no good. There's no 3, so we can't do 3. We can do 4. So now, if we use 4, what's left over? We got 8 left over, right? So 4 times 8, that adds up to 4. So those are the two numbers that we were looking for. Okay. So then it's -4 and +8. Let's do a quick check. -4 times 8 is -32. -4 plus 8 is +4. Okay. So then the top, you can factor out. I'm going to factor out a -1. I'm going to have x minus 4. So now they look similar, and now we're ready to cancel. This cancels this. We're left with x plus 8 under -1. Okay. Let's check that on Pearson. Let me go paper, get rid of my lines. Okay, -8 over x plus 8. I mean -1 over x plus 8. Okay, let's go here. -1 over x plus 8. All right. Okay. So on that note, we are going to end the session here. Let me check the chat to see if there are any questions. Okay. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Wait, so before I let you go, um, so the main thing for this week, gain full access to Pearson. Go ahead and complete those assignments. There should be 4 assignments and 1 quiz. That's what you're responsible for this week. It is a good idea to watch my lectures on YouTube, taking notes as if you're in class, and complete the assignments. That's my recommendation. I'll let you kind of work however you see fit. Email me if you have questions and get it done. All right, guys? Enjoy the rest of your weekend. And from one beautiful mind to another, take care. Peace. All right. Let's go here.